Assalamu alaikum guys. Now I will be speaking about the probability. Okay, this is one of the last topics that we will be doing this year, inshallah. Right, so the definition of the probability is this, guys. Say, let E be an event of sample space. Okay, the probability of event E is, right, P E equals to N E over N S equals to N over total. Right, where N is the number of outcomes in the event event E, and the total denotes the number of total outcomes in the sample space S or NS. Right, obviously maths doesn't really make sense with the definition, so we have to demonstrate that with examples. The probability is described. So basically what we do is this. Now when we speak about the probability, right, there are in the event, when an event is happening, there are outcomes. Right, we're going to look at the favorable outcomes and the total outcomes, right? So if I have to give this example, right, for as example of probability, it will be this. A coin is, if you toss a coin, guys, right, then it says find the probability of obtaining a tail. So when you're tossing a tail, how many options we have? You have a coin in your hand and you toss it. Obviously, you have two options, right? When that coin lands on the floor, it's either going to be heads or tails, right? So I'm just gonna write that here. So with tossing a coin, guys, we're going to have, right, two options, which will be, right, heads, or it's going to be tails. Now, the total number of the options, the outcomes, right? So when I am saying in this question, right, what will be probability that this will obtain the tails, right? So the total outcomes are this. How many total outcomes will? Because it's either going to be heads or tails when you toss the coin. There is no other option. So I am going to do this. The total number of outcome will be at the bottom, right? Write the total number, and then on the top, the numerator part, we're gonna write the number of favorable outcome. Favorable outcome means the one that is asked. So in this question, which one is that? So it's asked for tail. How many tails options we have here? One. So when you toss a coin, the probability that it's going to stand on tails is going to be 1/2. Now, if you write this as a fraction, is going to be 1/2, right? If we write as a percentage, remember we time with 100, then this is going to be 50/100, right? Or that is going to be, how we write it, we say 50%. Okay, and then if 50% of this probability is tails, then the other 50% obviously will be heads, because there is one option of heads, one option of tails. So total, we have two options. It's either going to stand on heads or tails. So when the question is asking what is the probability that it will stand on tails, then it's going to be 1/2. What is the probability of that coin stand on heads? Then again, it's going to be 1/2, right? Because the probability of heads is 1/2. I'm going to tell you how we're getting that. Probability of heads is also 1/2. 1/2 plus 1/2 is what, guys? That is going to be 2/2, and that is going to be 1, and that is basically 100%. So when we add the total number of outcomes together, it's basically going to be 100%. Right? So that's how we get it. And we're just going to look at the options, right? The outcomes, how many outcomes we have. Then we're going to say it's basically the number of favorable outcomes over total number of outcomes. Total numbers are how many outcomes we have, heads and tails. The favorable outcome is the one that is asked in this question, which was tails, so it's going to be 1/2. This is, right, the fraction. If the question is asking for the percentage, remember we just times it by 100. So we say 1/2 times 100 will be 50%. Okay. All right, let's look at the next examples here. We are rolling a die. What is the probability of, right, that die standing on an odd number? So guys, on a die, right, we have how many sides? We have 1, it's 2, 3, 4, 5, and 6. These are the numbers on a die, guys. So when you roll a die, obviously, because there are 6 sides on it, it's going to stand on one of these numbers because there are 6 sides and each side is represented by these numbers. Okay, right. So, for example, if I say now I'm rolling this die, what is the probability that the will stand on number 4? Right. So I am going to look at here. Now these are my outcomes, right? How many outcomes? 6, because I have 6 numbers. The question is saying, what is the probability that out of all these 6 numbers that this die will stand on number 4, right? So then number 4 is going to be my favorable outcome. So how many favorable outcomes I have here? There's only one number 4 here in this, right? So it's going to be 1 over 6, means there is only one number 4 out of all these 6 numbers. That's why the probability that this die will stand on number 4 is 1 over 6. Okay, right. Then if I say, like, okay, let's do the question like how it's asking the question. The question says, what is the probability that this die will stand on an odd number? So now here we're just going to have to know the odd numbers, right? Which numbers are odd? Let's just identify those numbers. Number 1 is an odd number. Number 3 is an odd number. Number 5 is an odd number, right? So my total outcomes are 6 because there are 6 numbers on die, 6 sides, and each side is represented by these numbers. So there are 6 numbers. So when you roll this die, it's going to stand on one of these numbers. But the question says, what is the probability it will the side that the roll will stand on is going to be an odd number. Then I'm going to look at my possible outcomes. How many odd numbers I have? 1, right, 2, and 3. I have 3 odd numbers. Then these are going to be my favorable outcomes. So it's going to be 3 over how many outcomes I have? Total outcomes are going to be 6, right? Then in math, guys, it's always important that you simplify things. So 3 over 6 is going to divide both sides by 3, right? If you if you divide 3 by 3, guys, right, then this is 3 by 3 is going to be 1, 6 divided by 3 is going to be 2. So it's going to be 1 over 2. 1 over 2 as a percentage, you times this by 100 is going to be 50%. So when you roll a die, guys, because there are 3 odd numbers, and how many even numbers there? 1, 2, 3, 3 even numbers. So 50% of probability is that this die will stand on one of these odd numbers, right? And 50% will be it will stand on one of the even numbers. Right, so the answer is going to be 1 over 2, and if you write as a percentage, it's going to be 100%. A coin is tossed 3 times. What is the probability of getting all the time heads? Right? So, when now we're going to do this, guys. So when we say you time this now, you toss the coin. Firstly, what is the probability that it will be heads or tails? It's 1 over 2, right? You see here for this question now, it's different than this one here, because now you're doing the same event multiple times. Because the event is what? To toss the coin. How many times you do it? 3 times. You're repeating the same thing, right? So, so when you do that, guys, say you 3 times. If you do it 2 times, your answer is going to be what? It's going to be heads or tails all the time. But the question says if you do it 3 times, right? You do it once, it's going to be either head or tails, right? And if these are the options in your one event, right? Either going to be head or tail. So if you toss the coin 3 times, say you are lucky enough, you're getting all 3 times, you toss it, it's head, right? It's head. Second time you toss it again you get head. The third time you did again, all head, 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 right? And then this is one of the options, like for you tossing this coin 3 times. This is one. And then when you do it 3 times, it could be head. First one you get head. Second one you get head, and the third one you get tails. This is also one of the options. Or you can see when you toss it, the first time you get head, second time it will be tails, and then the third time again you're getting head. This is also one of the options. Now when you toss it, the other option could be this. You get tails, right? Then you get head, and then again the third time again head. Now when you toss the coin, the other option will be this. You get the right tail. Second time it can be tail, but the third time it can be head. Or it can be what? It can be tail, head, and tails, right? That's also one of the options. So, and then finally, what can it be? It can be all 3 times. Like you toss the coin is tails. You toss the coin is tails. You toss the coin all 3 times. You get tails. So this is also one of the other options, right? And then let me think if there is any other thing that we can get. Right, or it can be a head, right? Tails and tails. That's also one of the options. So how many times? Let's say again, guys, because this here, the same event is repeating. That's why you see now this question basically saying when you have the coin, you toss 3 times. What is the probability of getting all the times heads? Right? So now we are gonna have to look at all the options. So 3 times when you toss the coin, it can be right head. And the second time you do it head, and the third time you do it head. That could be one of the options. Or is the first time you do it, it heads, second time it heads, and the third time it's tails. Or you toss the coin heads, second time tails, third time heads. That's one of the options. Or you toss the coin is tails first, and then heads, and the third time again heads. And then the other option will be if you toss the coin now, you get tails, tails, and heads, or you get tails, heads, and tails, or you get all 3 tails. Second time you toss it, it tails. Third time you toss it, it tails. Or you get first time you toss it, it heads, tails, and tails. So this may occur right in your event 1. This may occur 2. This may occur will be 3. This will be 4. This will be 5. This will be 6. This will be 7. And this will be 8. Right? So let's look at question now. These are all the possible outcomes that may occur. So the question says a coin is tossed 3 times. What is the probability of getting all the times heads? All the time. So basically, all 3 times you toss it heads. Second time you toss it heads, and then again you toss it heads. All 3 times it must be heads. So these are all the options, right? the possibilities that may happen. So from this one, I'm just going to look for all three heads. So when I toss it, it must be head. Second time head, and third time head. In which option it's like that? You can see here head, head, and head. So how many are here? One out of how many options? 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, the total number of outcomes, this is the total number of outcomes. It may occur like this, and then like it's asking the question, all three heads is only here. It's one option. So head, head, and head. So that's why it's going to be 1/8. That is going to be my answer. Okay. Let's see. Okay, so yeah, we have certain and impossible events, guys. An event whose probability is 1 is called a certain event. An event whose probability is 0 is called an impossible event. Guys, that is basically this. So let's look at this example, what they say here. You see this example, say we are rolling a die, what is the probability of, right? The number that coming up is less than 8. If you notice, guys, the numbers on the die, they all are less than 8 because 1, 2, 3, 4, 5, 6. So this is certain, 100%. The all numbers will be less than 8. Obviously, whatever number it stands on, it's less than 8. Right, so it's 100%. What is the probability that the number that the die will be standing on, there will be 9. Because all the numbers on the die, guys, is from 1 to 6. That's why there is no number 9. There's no way that it will stand on number 9 because it doesn't have that number. That's why it's 0%. It's 0% is what? It's impossible. Okay, it's certain all outcomes are this. Okay, this is right what they say. So it's basically this, guys. I'm just gonna show you here something. You see here, I'll tell you what this thing means, guys. Right, so this is 0%, right? Impossible. 0. And I'm going to say this 1, or I'm going to say 100, because 1 is 1 on 1, guys, is 100% right. So if I say, guys, right, I'm just going to give the examples. Okay, right. So now you're writing a test. There are two options, right? Say if you get less than 40%, that is a fail mark. If you get 40 and above, that is pass mark. So when you are writing a test, guys, you either fail or pass, right? So then how many options you have? It's 50% probability. 50% you fail, 50% you pass. Obviously, it depends on how much you study and stuff. But the 100% thing is this, guys. All right. Let me give you an example of 100%. Right. 100%, 100%. Okay, let's start from 0%. Right, 0%, guys, is going to be this. Say, for example, right, for a man giving a birth, it's impossible, right? Because only the females can give a birth, right? So if I say what is the probability of a man giving a birth, that's 0%. If I say what is the probability that, right, let me think of an example, maybe a nice example. Yeah, right. If I say, right, if you toss a coin, you either get heads or tails, right? The probability that you'll get heads or tails, that will be 100% because it's either heads or tails. So there is no other way. There's no other way that you get anything else. So that's going to be 100%, right? Or you say the weeks of right, we have 7 days a week. 100% information because 7 days a week is correct. We have 24 hours in a day. 100%, right? So we have day and night. The information is correct. That is 100%. So when something is correct undoubtedly, guys, so you don't doubt about it, so that is 100%, right? When something is impossible to happen, that is 0%. So now, then if 50-50, right, it's 50% obviously, right? It may or may not happen. Then if it's more than 50, it's like we call that likely. It's more than 50%, between 50 and 100. It's going to be likely, right? And then if less than 50%, right, is unlikely. So you look at something, you say it's going to happen or not, you can't decide. If you look at that, if it's less than 50%, the probability is less than 50%, we say it's unlikely to happen. You look at the weather, right? If it's cloudy, then you're going to expect rain, right? You say, okay, it's most likely it's going to rain, right? And then you, let me give this example. I look at you people now, I put the recordings on the um, Google Classroom, but people don't watch it. You don't watch, you don't learn, right? It's most likely you don't learn because you don't watch it. If you watch, then you will pass your test. Most likely you will pass. The revision recording is there. If you watch it, most probably you will pass because you will learn what is going to be in the exam. But if you don't watch it, then you will unlikely pass, right? So that is it, people. Let's continue to see what else we have. Calculating the probability. The probability of an event not to happen is equal to, right? Not is a keyword, which means complement. For example, the chance to not have 5 on the die is, okay, I'm going to explain this just like this. You see now, when we spoke about the die, we said there are 6 numbers on the die, right? 1, 2, 3, 4, 5, and 6. These are the numbers on the die. So when I say, right, what is the probability of, right, rolling a die that it will stand on number 2, right, number 2. So I'm rolling this die. Out of all these 6 outcomes, it must stand on number 2. What is the probability? How many number 2s I have? 1. So it's going to be 1 over 6, right? Now, this is when I say what is the probability that event will happen. I can change this question. I say, what is the probability that this die won't stand on number 2 and it will stand on any of the other numbers? What is the probability that it won't be standing on number 2? Then I'm going to say if, right, or how many outcomes I have? Total outcomes. I'm going to say 6 over 6, right? Minus one of them mustn't happen. So it mustn't only stand number 2. I'm going to take that out, right, that option. So minus 1 over 6, which will be 5 over 6. Right, so this is the probability that it won't stand on number 2. This is the probability that it will stand on number 2. So basically, when you ask, the question is asking you, what is the probability that that event is not going to happen? Then you look at all the events that, the probability that it is happening. Then you take, right, the probability of that certain thing that is not happening, take out. So because now, what is the probability that it will stand on on number 2? It's 1 over 6. Then take this out of all the outcomes. All the outcomes are what? 6 over 6. As you can see, it says 1. 6 over 6 is 1, guys. That's why. 6 over 6, because simplify this is 1. 1 minus 1 over 6. 6 times 1 over 6 minus 1 equals to 5 over 6, right? That's what I wrote here, 6 over 6, so you can understand clearly, minus 1 over 6, that will be 5 over 6. So the probability of this event not to happen is 5 over 6. Okay. Then we say, for example, an urn contains 5 blue, 4 red, and then 6 yellow marbles. We want to draw a marble from that, and right, the probability of drawing red or yellow marble is what? So I'm gonna look total, how many I have? 5 blue plus 4 red and plus 6 yellow. Add them together, it's all together, it's going to be, right, 15. So for blue, it's going to be what? Okay, 5 over 15. Then it's going to be 4 over 15, and then 6 over 15, right? Because this is blue, right? Red, and then yellow. Okay. The question says we want to draw a marble from that urn. The probability of drawing a red or a yellow marble is what? Red or yellow? Red and yellow. Add them together, right? Red is 4 over 15. Yellow is 6 over 15. Then add these two together, right? Add them together. It's going to be what? Equals to 10 over 15. Right? 10 over 15. Simplify that. Divide both sides by 5. 10 divided by 5 will be 2. And then, oops, 2, 15 divided by 5 is going to be 3. So that will be 2 over 3. Right, instead of formulas, you may use Venn diagram in the complement union intersection sets. We can always use, right, an OT for the probability of questions. We can use that as well, but we're not doing the set and operation. That's why we're not going to do that. Okay. Right, so next question. Okay, there are a few questions here. We just let's look at these questions. It says estimate the probability of each event given below. State if the probability is below average, right? 50% chance, 50-50, right? Above average, certain, impossible, or if you cannot tell because not enough information was given. Event A, this says next baby to be born will be a boy. Right, this is completely a separate event, right? You see now, when someone is giving a birth, there are two options. It's either going to be a girl or going to be a boy. So the probability is always, right, 1 over 2 for boy, 1 over 2 for girl. So 1 over 2, and then time it by 100 as percentage, it's going to be 50%. So when somebody is giving a birth, guys, 50% that is going to be a boy, 50% probability that is going to be a girl, right? So when a triangle will have 3 sides, it's 100%. It's accurate triangles because it has 3 sides. It is what is the M? It was here in the question. It's certain because triangles have 3 sides. Bafana will win the 2030 World Cup soccer, right? But for this one, it's not, enough information is not given because for that there are a few steps. Obviously, it must be in the file. Say if it is qualified for, right, the World Cup, then obviously you're playing finals. You either lose or you win. So there will be 2 options, 50%. But like I said, the information is not clear. That's why we passed this. Afro will be the next captain of the soccer team, right? 0%. There is no such thing, right? The following table is a summary of the ages of learners in grade 9. Okay, this question, class. Right, so how many boys are here in this class? Let me just clear this. Okay, so 15 years old, 16 years old. The boys, there are 4 boys in this class who are 15 years old. There are 14 boys in this class who are 14 years old. 16 years old, right? There are 6 girls who are 15 years old in this class. There are 6 girls in this class who are 16 years old. Let's look at the question. How many learners are there in the class, right? So how many learners all together? How many boys are here? 4 plus 14, 18 boys. How many girls? 6 girls, 15 years old, 6 girls, 16 years old. So altogether, 12 girls. 18 plus 12 will be 30. So there are, what are we going to say? We're going to say there are 30 girls, right? We just basically add them together. This is going to be 18. This is going to be 12. Add them together. 18 plus 12 will be 30. Right, what's the, is it the probability that grade 9 learner is a learner that is 15 years old? Is a learner. How many learners are 15 years old? It doesn't say girls or boys, guys. It just says a learner. Can be a girl, can be a boy. So we're going to say how many? Right? 10 learners. Right? So how many? 15 years old boys, 4 learners, and 6 learners. Okay. But it says if the teacher picks any learner, what is the probability that it's going to be this? So the favorable outcomes, 4 boys plus 6 girls who are 15 years old. So it's going to be 10 out of how many learners we have in this class? So that simplified is going to be 1 over 3. Okay. Then it says if the teacher picks any learner, what is the probability that that learner is going to be a boy or a girl? Now, how many girls are in this class? 6, 15 years old, 6, 12 years old. So they are 12 out of 30. Simplify this, right? We can divide both sides by 6. This is going to be 2 over 5. So this is, right, the girls. Let's see how many boys are here. 18 boys. Then I'm going to do boys here. 18 over 30, right? And then I will divide both sides by 6. I will simplify it. The 18 divided by 6 will be 3. 30 divided by 6 will be 5. Okay. Right. So when this teacher picks any learner from this class, the probability that that learner is going to be a girl is 2 over 5. The probability that that learner will be a boy is 3 over 5. Why? Because we look at the number of the girls in class and the number of the boys. Then we look at the total number. Number of the girls over the total number of the students in class will give us, right, the probability of the chosen learner to be a girl. Then number of boys over the total number of students in class will give us the probability of the chosen learner to be a boy. Okay, so that is it. Okay, let's see if there's anything else. Right, there's nothing else. So yeah, that is it.